We're going to look at our horizontal translation. Another word for horizontal translation is phase shift. And that right there is our d value in our equation. We're going to be adding it or subtracting it from the theta. The d value always shifts the opposite direction as the sign. So notice that this is a negative, so that means d is actually a positive. With our first example, what we have is a phase shift of negative pi. That means that we're going to shift all the values to the left pi. Now, if we remember, for sine and cosine, what we have is theta. Our theta values are 0, pi halves, pi, 3 pi over 2, and 2 pi. Now, because we're shifting them to the left pi, that means we're subtracting pi from each of our values. So when we're filling out our table for the first one, what we're going to do is we're going to go 0 minus pi, which is negative pi. Then we're going to go pi halves minus pi, which is negative pi halves. Pi minus pi is 0. 3 pi over 2 minus pi is pi halves. And 2 pi minus pi is pi. So that right there would be how we get our theta values. Now, if we're looking at our equation, what we're doing is we're subtracting 1 each time. So our normal sine values are 0, 1, 0, negative 1, and 0. So if we're subtracting 1, we get negative 1, 0, negative 1, negative 2, negative 1. When we graph this, I'm going to start off with negative pi, and I'm going to end all the way with pi. So at negative pi, it's down 1. Then we have 0, we have negative 1, we have negative 2, and we're back at negative 1. So this right here is our sine value. Notice that it shifted to the left by pi. Now for the next one, this is a little bit more difficult because we have a frequency of 2 and we have a phase shift of pi. So what we're going to do is we're going to fill out our chart. And since it shifts to the right pi, that means we're going to start with pi. Now, if we look at our frequency, this is a 2. That means if you remember, our period is 2 pi over 2, which is pi. So that means that if we start at pi and our period is pi, we're adding pi to it. So we end at 2 pi. Now, if we start at pi and we end at 2 pi, in between pi and 2 pi would be 3 pi over 2. Now, what we're going to do is we're going to look at in between pi and 3 pi over 2, and that would be 5 pi over 4. And then 3 pi over 2 and 2 pi would be 7 pi over 2. Now, what I'm doing is I'm finding the middle of each one. So just as an example, pi plus 3 pi over 2, really what I'm doing is I'm adding 1 plus 1.5, and I'm dividing it by 2. And when I divide it by 2, I'm just writing it as a improper fraction. Now what I'm going to do is I'm going to fill in my y values. Notice that we're multiplying by 3 and we're adding 1. So my normal cosine values would be 1, 0, negative 1, 0, and 1. So when I plug it in, 1 times 3 is 3, plus 1 is 4. 0 times 3 is 0, plus 1 is 1. Negative 1 times 3 is negative 3, plus 1 is negative 2. Then we have 1 and back to 4. So when we're graphing this, we're going to start with pi, and we're going to end with 2 pi. I'm going to go up to 4. And what I have is pi 4, then 1, then negative 2, back to 1, and then back to 4. Now for this next one, I'm going to show you another trick. The first trick was seeing where it starts, seeing what the period is, and adding that period to the end. Now, another way of doing it is to take this expression right here and set that equal to each of our tangent values. So remember, our tangent values are different than our sine and cosine values. What we have is negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. So one thing that you can do is you can solve this algebraically. So you could take the 1/2 theta minus pi halves, and you set it equal to each of our values. So we're going to set it equal to negative pi halves. Now when we solve this equation, we're first timesing it by 2, and that would give us negative pi, and then we add pi halves, and then that would give us, for our first value, negative pi halves. Now for the next one, what we're going to do is we're going to plug in the negative pi fourths. We're going to times it by 2. That would be negative pi halves. Then we're going to add pi halves to get 0. For our next one is 0. We times it by 2 in order to get rid of the 1/2. That gives us 2. That gives us 0. Then I add the pi halves to it to get pi halves. Now, sometimes what you can do is you can see the pattern of the number. And we can see in this case that each of them are going up by pi halves. So that way we know that the next one is pi, and the next one is 3 pi over 2, if we're adding pi each time. Now, if we're looking at our values, notice that what we're doing is we're multiplying by 3 and subtracting 4. With tangent, it starts undefined and it ends undefined. We have negative 1, 0, and 1. So if we plug in a negative 1, that's negative 3, minus 4 is negative 7. If you plug in a 0, we get negative 4. If we plug in a 1, we get negative 1. So we're starting with negative pi halves. We're ending with 3 pi over 2. So we'll go by 2's. And we have 0, which is negative 7. Then we have pi halves, which is negative 4. And then what we have is at pi, we have negative 1. We have a vertical asymptote at each of our ends. Okay, let's look at the next one. With the next one, what we're going to do is we don't have a period, so it's a little bit easier. we're going to add pi halves to each of our values. So remember that our first value for cosine is 0. If we add pi halves, we get pi halves. Our second one is pi halves. If we add pi halves, we get pi. Our third is pi. If we add pi halves, we get 3 pi over 2. Now, if you're looking at the pattern, notice that we're adding pi halves each time. So that means that the next one is 2 pi, and the next one is 5 pi over 2. So what we're going to do is we're going to add 2 to each of our cosine values. So we have 3, 2, 1, and then 2 and 3. We're starting at pi halves. We're ending at 5 pi over 2. We're going to go up to 3. And so we have 3, 2, 1, 2, 3. Now looking at letter E, what I'm going to do is I'm going to do the algebra approach, just to kind of give us a handle for that one. With the algebra approach, remember, we're just taking our expression right here, and what we're doing is we're solving each of the values. So for the first one, it's 0. And it's basically a two-step equation. I multiply by 2, and I subtract the pi. So when I multiply by 2, I get 0. Subtract the pi, I get negative pi. For the next value for sine, what we have is pi halves. I multiply by 2, that gives me pi. I subtract pi, I get 0. For the next one, I multiply by 2, that gives me 2 pi. I subtract pi, that gives me pi. Now, if we're looking at the pattern, notice that we're going up by pi. So the next one would be 2 pi and 3 pi. When we're plugging in our values, notice that we're multiplying by 4 and subtracting by 2. So the first is 0, times 4 is 0, minus 2. Next one is 1, times 4 is 4, minus 2. Then we have 0. The next one is negative 1, which is negative 4, minus 2 is negative 6. And then our last one is negative 2. So we're going to start at negative pi, and we're going to end at 3 pi. We go to negative 2. Actually, I'm going to go by 2's. And so I have negative 2. I have, oops, wrong spot. I have negative 2. I have 2. I'm back to negative 2. I have negative 6. And then back to negative 2. Now for the next one, since I don't have a period, or I should say my period is just pi, what I'm going to do is I'm just going to subtract pi halves from each of them. So with this right here, if I normally start with negative pi halves and I subtract pi halves, then I get negative pi. My next one is negative pi fourths. If I subtract pi halves, I get negative 3 pi over 2. Sorry, 3 pi over 4. Then if I take 0 and subtract pi halves, I get negative pi halves. And then if I take pi fourths and subtract pi halves, I get negative pi fourths. Notice that I'm going up by a fourth each time, so the next one has to be 0. Tangent's really nice for the y's because I start with undefined and I end with undefined. Remember, it goes negative 1, 0, 1. So when I plug in a negative 1, negative negative is a positive. When I plug in 0, I get 1. And when I plug in 1, I get 0. So I'm starting at negative, this one right here, I'm just going to call this negative pi. And then I'm going to call this 0. So I have a vertical asymptote at the beginning and at the end. And then what I have is 2, 1, and 0. Notice the tangent curve is going down because it's negative tangent. So we're going to switch. What we're going to be doing now is we're given a graph, and what we have to do is come up with an equation. Now, what we're going to do with the equation is we're not going to have a phase shift. We're just going to use our A, B, and C values. So we're going to have our A value, our trig ratio, and then it's going to be B theta plus C. And that's how we're going to solve each one of these. What I always like to do is start with my midline. That's the middle of the graph. So if the highest is 4 and the lowest is -4, that means that my midline is at 0. If you're not sure how to do it, you add them up and you divide by 2. So that means my equation, I'm going to add 0. I'm just putting plus 0. You don't have to put a plus 0. My trig ratio is going to be sine. And the reason that it's sine is because it starts in the middle, goes up, down, and then back to the same spot. From the middle, our midline, to the peak is a distance of 4. So I'm putting 4 sine. And notice that my period is 2 pi because that's when it completes the full cycle. And the formula is 2 pi over b. So that means my b value, or my frequency, has to be 1 for that equation to work. So it's just theta. Now for letter B, I see that it's a cosine curve because it starts at the top, goes down, and goes back up to the top. So I know that I have a cosine curve. My midline in between 5 and -3 would be 1. Once again, if you're not sure, we add them up and we divide by 2. So that means I'm going to subtract 1. From the middle to the peak or the valley, in this case, is 4. So I'm going to put a 4 right here. And notice that my period is pi. So if the period is pi and the formula is 2 pi over b, in order for this to be equal to pi, my b value has to be 2. Now notice that it's cosine and it's going up, down, and then back up again. Why that's important is because when we look at the next one, notice it's starting at the bottom, going up, and then back down again. So we know it's cosine, but in this case, it's going to be a negative cosine. So we just want to remember that it's going in the opposite direction. We're going to start with our midline. 8 plus -2 divided by 2 gives us 3. So we have a midline at 3. 3 to the peak is 5. Remember, it's a -5 because cosine's going in the opposite direction. And if we're looking at it, my period is pi halves. And if we look at our formula, it's 2 pi over b. And so in order for this to be equal, my b value has to be 4. And that would be my equation.